Every technician knows you need three things to get an engine running: the proper air-fuel mixture, a good compression of that mixture, and finally, a spark to initiate the combustion process. Now today on the trainer, we're going to focus on the latter, getting the spark to that air-fuel mixture. And we're going to take a look specifically at coil-on-plug ignition systems. Stick around. Today's episode is sponsored by Autel. Learn more about the complete line of Autel diagnostic tools by visiting www.autel.com. Every technician knows you have to have three things for an engine to run: compression, fuel, and spark. Our focus today is going to be on the latter, spark, as delivered by a coil-on-plug ignition system. But before we dive into the different types of C.O.P systems and how to test them, let's review first how a basic ignition system functions. At the heart of the system is the ignition coil. The ignition coil is a transformer, and it contains two windings, a primary and a secondary. Now the secondary windings are substantially more than the primary. This allows the voltage to be stepped up, and that's what produces enough voltage to overcome that air gap and fire that spark plug. The system function is also pretty simple. Power supplied to the primary and the ground side of the circuit is controlled by the engine control module or a dedicated ignition control module. This device is responsible for opening and closing the circuit. Now when the circuit is closed, current flows through the primary, and that results in a magnetic field that builds around those primary windings. But where the real magic happens is when we turn the power off. Now that magnetic field collapses, and as it does, it induces voltage and current in that secondary winding, and of course, because of the increased number of windings in comparison to the primary, the output of the secondary is indeed much higher. On some modern coils, it can reach as high as 70,000 volts. Now, of course, the ignition coil is not the only component in the ignition system. And in the case of the coil-on-plug systems that we're focusing on today, we need to understand the different designs that you are going to run into. They are the 2-wire, 3-wire, and 4-wire designs. And of the 4-wire designs, there are two variations. One containing an integrated feedback circuit, and the other makes use of a double ground. Let's start by talking about the 2-wire coil-on-plug ignition system. It's probably the one you're going to be most familiar with because it's the same 2-wired idea that you're already used to seeing in distributor and distributorless ignition systems. One wire is supplying constant power to the primary side of the coil, and the other is the ground side of the primary, leading to either the engine control module or a dedicated ignition control module that controls the operation of the circuit. Now on some designs, the ECM monitors any voltage spikes that might occur in the ground side of the circuit just to make sure whether that coil fired or not. Fiat Chrysler PCMs can also monitor the burn time of the secondary event. You'll see this as a data pit on your scan tool. It monitors this in order to set any coil ionization fault codes, or DTCs, when it detects a problem with any portion of that burn time, whether it's too short or insufficient or didn't occur at all. Now let's move on to the 3-wire design. This is a little different. Yes, 2 wires still supply power and ground, but they're supplying it to the integrated electronics within the coil assembly. We've moved the ignition control module from outside inside the coil assembly itself. That 3rd wire, and that's why we have to have that, that is the trigger signal from the engine control module telling that ICU when to fire the spark plug. Now let's talk about the first variation of the 4-wire design. Very similar to the 3-wire, we have power and ground and a trigger going to the integrated ignition control unit But the fourth wire is actually a feedback signal to the ECM to let the ECM know that the coil did indeed fire. The second variation of the four-wire design makes a different use of that fourth connector pin. In this case, it's a secondary or double ground. Internally, there's power and ground going to the coil assembly, but there's a separate ground for the ignition control unit. And now that we've got an overview of the different types of coil-on-plug ignition systems you may run into, what do you say we go under the car and see how to test these systems? The first vehicle that we're going to do some tests on is a 2004 Mercury Sable with a 3.0 liter Duratec 24 valve engine. It uses a two-wire coil-on-plug system, and we're going to start off with some non-scope tests first. The very first check that we should do on any of these systems is a performance test. Do we have a good strong spark or do we not? And the easiest way to do that is with a tool like this one. A coil can easily fire a spark plug when it's outside of the engine because it isn't under the high pressure it would be normally. So this type of test is irrelevant and proves nothing. The tester allows me to expand the air gap, demanding more energy from the coil and stressing it to its limits. If it can pass this simple test, the coil is fine. If for any reason you suspect that you have a weak spark or of course a no spark condition, we can move on testing using something as simple as a test light. And we'll also show you how to do these tests using your DVOM or digital volt ohm meter. If you have a no spark condition or even a weak spark condition, the easiest first step is to disconnect the coil, key on engine off, and check for the presence of power. If you find that you do have power on the circuit, you can also use your test light to look for the trigger signal on the ground side. We'll disconnect it with the engine running, insert it now into the ground side pin, and see if we get any kind of a flash. So we can also test the system using the multimeter or DVOM function on the MS919. You see it's on DC voltage, our ranging is correct. And again, what you're seeing here is ghost voltage. That's, you see it bouncing around, it means we don't have a good contact. In fact, we're not even connected. If I do touch the leads together, now we have a good connection, no ghost voltage, we know we're getting an accurate reading. So we're going to start by putting the negative meter lead at the battery, and then we're going to check for power on the coil. And we should see system voltage, in this case charging system voltage with the engine running. If I want to do a quick check of the voltage drop on the positive side of this circuit, I can just move my negative meter lead from the negative battery post over to the positive post. You can see that we have 175 millivolts of voltage drop in that side of the circuit. Not a big deal. Now I can't do the same thing on the negative side of the circuit because again that's being controlled by the engine ECM. But what I can do is check to see if I'm getting a good trigger signal, and what I'll do is I'll remove the probe. I'll go and set this now to frequency. I'm not sure what kind of a range I'm going to get, so I'll leave it on auto. And I'm going to back probe now the ground side of the coil. The fact that I'm getting a frequency measurement tells me that I am getting a trigger from the ECM. So now we can move on to testing this using a scope. A word of caution before you connect your scope to the primary side of the ignition coil. This also applies if you're going to connect to a fuel injector or any other device that works with a coil wire magnetic field. When this field is collapsed, it creates what's called a flyback voltage in the circuit. A flyback voltage that just might exceed your scope's maximum input value. And if that happens, you're going to let all the smoke out of your scope. In other words, you're going to toast it, and we don't want that to happen. So make sure that you know what that maximum input value is for your scope. Some older ones are around 50 volts. Most of the newer stuff is around 200. And be on the safe side. Use a device called an attenuator like this one, installed in line with the meter lead or the scope lead. Now what this does is it steps the voltage down going into your scope by a factor of 10 or 20 to 1, depending on the attenuator. This protects your scope without affecting the pattern that you see on your screen. Now, if you have the option, make sure you go to your probe menu and select the appropriate attenuator so that the voltage scaling is correct. All right, let's start off with the scope setup. We're going to go into the MS919. We're going to pull up measuring tools, choose oscilloscope. And we have 3 channels that we're going to be using here. The first one is going to be channel A, and we're going to set that on the 20 volt scale. I like going by the 20-20 rule when I'm starting off with my scope. The first 20 means that I want a voltage range of 20 volts. That'll cover just about everything on the 12 volt system I want to look at. Probe setting in this case is just the standard probe times 1. And now we'll move on, excuse me, to channel B. Now channel B I have on the ground side of the coil, and as I talked already about making sure that we have the probe settings correct. So let's do that first. We're going to go to probe setting, and in this case I have a 10 to 1 attenuator attached. So I'm going to put that on, and then we'll go back to amplitude setting. And we're going to start off kind of high because, like I said, you can have some pretty high flyback voltage. I can always tone it down in order to improve my pattern. C, I'm going to do something a little different here. Here, I'm going to select a current clamp, a low current clamp to be precise, and we're going to go to the 1 millivolt range, equals 10 milliamps. And we're going to set the probe here. Now it's going to do the scaling for me, so I don't have to worry about that. Then we'll go to amplitude setting. Again, we'll start with 10 amps and see where that takes us. And then finally on the time we're going to select 20 milliseconds per division. Where you are. That's the other 20 of the 20-20 rule. That's going to give me 1 rotation, complete 720-degree cycle of the engine at idle. So let's make sure I'll get something on the screen. So with everything hooked up, let's go ahead and see what we got. Now also to give you a quick look at exactly where I'm connecting to, I'm just back probed into the ignition coil that I want to test. Red channel is attached to the B plus connection. The red, in this case, it's a red wire going into the coil. As you can see from the scope pattern that we're going to capture, that should be relatively flat and unchanging. Really don't need it in terms of the diagnostics, but I want you to see what everything's doing in terms of that coil design. The green probe is on the ground side of the coil. We do have an attenuator in line in order to protect the scope, though I don't think we have enough voltage really to hurt that. And then, of course, the low amp clamp there, let me zoom out so you can see that better, is attached or clamped around the wire, allowing me to read or get a view of the current in that circuit. You know, in the 2-wire system, there's a lot more information that can be had using a scope than merely checking the coil's performance. All right, so let's open it up a little bit and see if we can spread these out where we might be able to see them a little better. We'll just pull glue down, and we'll move the thread up. There you go. Oh, sorry, I got the green one. Yeah, it doesn't matter. We'll leave the green one up then. And you can see right now that the blue is inverted. Now I can change the probe, or I can go into the menu. Ah, here we go. Missed it, went right by it. So We have it inverted. And now you see where it's turned that around. Now I can set a trigger. We'll go ahead and set a trigger. And we'll just leave it at auto on, we'll use channel B since that's doing something. And now we've stabilized the pattern. Still don't have a lot that we can see, so let's adjust the time base so we can open that up some. So let's get that down from 20 to 5 milliseconds and see what that gives us. Okay, I think we can open that even more. So let's bring that to 2 milliseconds. And now we've got a really cool pattern on the screen. We're going to freeze that and talk about that. What you're seeing here is not atypical for some older Fords. It's called a multi-strike ignition system. And what you're seeing here is 3 quick ignition events occurring at idle. This is to help ensure complete combustion of the air-fuel mixture. And going along with that, you see the coil current ramps, the coil current building in the coil for each of those strikes. This is all great diagnostic information above and beyond just assessing the health of the coil. A lot of information can be found in that burn line in terms of what's going on inside the engine itself. And something that's very valuable. It's a whole nother lesson in learning how to read that. I do want to point out that this is taken on the primary side, but it's a great replication of what the secondary pattern is going to look like. The firing voltage, though, that's not going to be the same. You really can't use that in terms of your diagnostics. But as far as the spark event, the burn time, all of that's the same. The other beauty, again, is in the current, making sure that the current flow is building quickly, turning off quickly, and there's no dropouts in the current flow. That's a good indication of the health of the circuit and the windings in the coil itself. Ideally, I'd like to check that on all the coils at once, and that way if there is a coil that's got a problem, it's going to stand out really quick. The next vehicle we're going to take a look at is a 2014 Scion TC with a 2.5 liter engine. Now this vehicle uses the 4-wire Coil-On-Plug design used by Toyota. And what does that 4th wire do? It provides an integrated feedback to the ECM. Now, testing this coil is similar to the 3-wire system, so we're going to cover both using this vehicle as our demo. Before we can start testing anything, we need to pull up a schematic for the vehicle. And that's one of the nice things about the Autel tool, is I can access motor information systems directly through the tool. Now this is based in the cloud, so I do need Wi-Fi connected in order to access it. Now we'll go ahead and put in the specifics for our vehicle. Remember, we had a 2014 Scion. Wait for that to populate. And now we can scroll down to wiring diagrams by system. And then engine. Finally, excuse me, my little stubby fingers, a little hard to get in there. So now we have the ignition system. Now, the first thing I want to call to your attention is that this is not your typical block diagram. This is a factory diagram. So this first half is power coming in. I'm interested in the coils directly, so we're going to go over here to number 2. See, there we go. And let's blow that up where we can see it. Maybe down a little bit. Yeah. All right, so we can see here the white with black tracer is ground to all the coils. Then we have B plus coming in here on the red wire to all 4 coils. We have the yellow wire is the IGF, that's the feedback to the ECM. And then we have individual triggers for each coil. We have a white, let's see, turn that, I can't quite see that one. But we have 4 trigger coils, 4 trigger wires to each coil from the ECM. We're going to take a look at coil number 4. So let's see if I can bring that up a little bit more so we can see it even better. And then we can see here that, again, white and black ground, IGF signal is a yellow wire, B plus is red wire, and then IGT4 looks to be like a black wire here. Now that we know what wires go where, it's time to start testing. The first series of tests we're going to do are those you can make without a scope. I'm going to begin this test using the multimeter function of the MS919. So we're going to select DC voltage, and then we need to select an amplitude. Let's call it 30 volts because we're going to have, well, 10 volts per division. Let's put this on by division. No, we don't need that. So we want a total range of 30 volts so we can cover any 12 volt reading that we have. I apologize, you can't see the negative battery post, but here's the negative terminal meter. I'm going to put that right on battery ground, keys on. And now I'm going to use the positive meter lead to back probe the power wire carefully and see what we get. Turn this off so we can see it. There we go. So there you can see 12.09 volts. So I'm getting battery to the coil. But this is really not a conclusive test. I want to see what if there's any voltage drop in the circuit. Is there anything that might be causing me an issue? Now I can do that very easily here by measuring at the battery, and then again here and doing this subtract the difference. For example, if we look at here, we got 12.09 there, and if I touch the battery positive post, we got 12.13. So that's telling me that there's 0.04 volts or 40 millivolts of voltage drop in that circuit. Now that's nothing. That's really nothing to worry about. So you can do a more direct test though. We'll put this back, and it's very simple. We're just going to put the positive, and then we're going to take the negative cable and put it at the positive battery post. So now I'm just checking the positive side of the circuit, and you can see what I'm reading, 35.6 millivolts, right in there with what we saw when we were subtracting. Now this is the way to do a voltage drop test. The circuit is loaded, the coil's loading the circuit. This is a very good indication that there's no problems on the positive side of the circuit. But this coil design, because the ground is just that, a ground, it's not being triggered by the ECU. Remember, the trigger is separate, it's a separate function. We can also check the ground side of the circuit while we're here. All we have to do here is we're going to move my meter lead to the ground side of the coil, the ground wire, and we're going to move the negative meter lead back to the negative battery post. And you see the ground side voltage drop is only 5 millivolts. Absolutely nothing to worry about there. Now, I do want to show you one other thing when we've got the meter hooked up. When I take the meter leads loose, you're going to see the leads bounce around a little bit. This is called ghost voltage. It's good to know because if you see your reading bouncing around, you're not getting good contact with your meter leads. See what happens when I actually put the meter leads together. Now it's nice, stable, dead zero. I know I've got good contact with my meter leads, and I'm actually getting an accurate reading. Just something for you to remember. All right, now the next step, got to talk a little bit, the engine's running. We're going to now set the meter up to read frequency, and I'm going to use the auto setting here, so I really don't know what to expect. And we're going to check the trigger signal or the presence of the trigger signal next. So what I got here is I have my negative meter lead is connected to the ground of the battery, and then I'm going to back probe the signal wire, the trigger signal, at the coil. The presence of the frequency is telling me that I am getting a trigger signal to the coil. The ECM sends a 5-volt bias signal on the IGF circuit to all 4 individual coils on a single line. Internal electronics in each coil monitor the coil operation and pulse the IGF to ground when the coil fires successfully. The ECM monitors this signal, and when it doesn't see the 5-volt being pulled to ground, it sets a code for that coil. Now let's connect our scope and see what that has to tell us. We're going to begin the scope test, first selecting the scope module again on the MS919, and then we're going to set up the individual channels I've already got the back probe pins in place. Don't know if they're secure yet or not. Channels leads are set up on the scope, so we'll just get right into it. We'll start by setting up channel A. We'll have it on DC voltage. I want about a 20 volt scaling because right now everything's going to be somewhere in that 12 volt range. We can use that to start. Probe setting, we want to point out, ×1 is already set. That's if you're using the regular leads. It's like we talked about earlier in the 2-wire system when you might need a 10 to 1 or 20 to 1 attenuator and how you can use that. Just wanted to refresh your memory on that. All right. B, we'll use that one here. That's the green channel. Again, same thing, DC, 20 volt. C, we'll do the same thing. 20 volt. And then finally, we'll pull up the 4th channel and also set that to 20 volt. Now, I'm going to hook up to all the leads so that you can see what they do relative to one another and help draw that home of what those 4 wires are doing. Remember, we talked about on the integrated feedback circuit, power, ground, trigger, and then feedback to the ECM when the coil fires. So let's go ahead and set that up. We'll start with channel 1. It's going to be pretty much a reflection of system voltage, and that can help me again with the voltage drop issues, spotting a voltage drop issue. And let's see, put that there. And I'm going to go ahead and start the car as well, and let me go ahead and set up the trigger options and time divisions, which I haven't done yet. Time divisions, remember we talked about the 20/20 rule in other videos. Basic initial scope settings when I'm doing something I haven't done before. The first 20 is the range, 20 volts, which covers just about all the 12 volt circuits on the vehicle. And the other 20 is 20 milliseconds per division. So we'll pull that up. There we are. And what this does, it gives me 2 full revolutions of the engine on one screen at idle. So I tell you what, we're going to pick it up a little bit more. So let's go to 100 milliseconds. We can always back that down again. So now we'll be sure we're going to get something on the screen. So I'm going to go ahead and start the car and we'll connect the channels and we'll see what we got. All right, first one is the B+, battery plus to the coil. Okay, a little bit of noise, nothing too bad. We see you have that. The next one, we're going to use, since it's a yellow wire, for the feedback circuit, I'm going to go ahead and use that one. Get our ground in place. Make sure that's nice and stable. And now we'll connect that. So we have a signal there. Next is our green. See if I can pull that out without making too much of a tangle here. And we'll get our ground lead in place, make sure that's solid. Now that is ground for the coil, so appropriate. And then finally, our blue. Our blue is going to be the trigger signal from the ECM. So we'll get that ground stacked on there. Make sure I get that good and solid. And we'll get into that blue one there. And see if we can pick that up. Let's slow down the time a little bit so we can see a little bit better. Let's try 50. go to 20. See what that looks like. Now we're going to separate it up a little bit so we can see. So we're just going to drag this down a little bit, separate that feedback signal out. Set the blue. Not getting a signal on there yet. I don't have a good connection there, so let's check those connections. There we go. Now we're getting something. Let's spread it out a little more so you can really see those patterns. Let's bring it down to 5 and see what that looks like. Okay, great. Now we're getting somewhere. Now we're just going to put a trigger in there to help stabilize the pattern. And I really don't have it set anything in particular. You know, I think I could probably move it down a little bit. And we'll trigger it off of, oh, let's see, channel. That would be C. A little bit, and here we go. Let's go ahead and we'll freeze it right there. And I'm going to freeze that, turn it off, we'll talk about what we got. So let's zoom in and take a closer look. Now that we have the capture frozen, again, red, that's system voltage, so we can see what that voltage level is. Roughly 14 volts. Okay, so the engine running, that's fine. Dropout could be something as simple as an issue with the connection there. Not too worried about that. But if I had a voltage drop issue, I would see that, of course, lower than what it should be. Same on the ground. You see the ground, we're right there at the 0 line. Remember we measured it earlier, it was only 5 millivolts, so that's telling me everything's okay there. And then we have the blue, that's the ECM trigger. We can see that that's, let's see, we'll move the ground up a little bit so we can get some more room for the trigger. And we'll try to get it right on that 0 line there. But you can see that that's roughly 5 volts. And then here we have the feedback. So when the coil fires, that IGF, that 5 volt IGF is pulled to ground, and that lets the ECM know that the engine, that the coil did indeed fire. If you recall, I did mention that there are 2 variations of the 4-wire coil-on-plug design. In the second design, that 4th wire is actually another ground. Specifically, it's a ground for the electronics in the coil assembly itself. This is separate from the other ground, which is taking care of the primary side of the coil. Now, if something happens to that reference low circuit, as GM calls it, the coil will still maintain functionality. Well, we sure have covered a lot today, haven't we? I hope you found it helpful. And I'll include some references in the video description that you can take a look at when you get a chance to help you further your drivability diagnostic skills. And consider, professional diagnostics requires professional tooling, so be sure to check out the entire line of Autel diagnostic tools at www.autel.com. And as always, thanks for watching.